Hello, Spartan fans. 7.1 composite inverse trig functions and 7.2 composite inverse reciprocal trig functions. I'm going to blend it all into one. First thing I'm going to do is review the domain and the range of the inverse sine, inverse cosine, and inverse tangent. So y equals the inverse sine of x. The domain is -1 to 1 included, and the range is -π/2 to +π/2 included. Cosine. Domain is -1 to 1 included, and the range is 0 to π included. And then the tangent. The domain is all real numbers. Oops. And the range is -π/2 to +π/2, not included. Not included. You need to go back, pause the video. Let's look at the reciprocal trig functions. So the reciprocal function of sine, not the inverse, the reciprocal trig function of sinus cosecant the domain of the reciprocal trig function is going to be absolute value of x is greater than 0. How about 1? Greater than 1, sorry. And the range is going to be the same as it is for the sine, only not included because there are asymptotes. Not included because there are asymptotes. The reciprocal function to cosine is secant. The reciprocal function to cosine is secant. The domain is going to be the same as it is for the inverse cosecant. Absolute value of x is greater than or equal to 1. And the range is going to be from 0 to π, only not included because there are asymptotes. And for cotangent, which is the reciprocal function to tangent, the domain is going to be all real numbers. And the range is going to be that should be 0 to π. Cotangent has cosine, same asymptotes as the reciprocal cosine, which is secant. These share the same asymptote, so it's from 0 to π. I'm not going to show you the graphs of these. Feel free to plug them into Desmos. You are not responsible for knowing the inverse functions. I highly recommend, though, that you know the parent cosecant, secant, cotangent. It's very helpful. Okay. All this can be found in the book, of course. So what we're going to look at is evaluating a composite function. Composite function is a function of a function. So let's look at something like the inverse sine of the sine of -π/10. Okay, let's work inside out. This right here is a side length of a triangle. This represents side length of the opposite side of the angle negative pi over 10. That's what that represents. It's a side length. So if I asked you to find the sine of 30 degrees, you would say 1/2. If I asked you to find the sine of 629 degrees, you would find 629 degrees, and then you would find the value of its sine. So negative pi over 10. It's pi over 10 in the fourth quadrant. Negative pi over 10, so fourth quadrant. Well, its side length is whatever this is. Let's just call it t. Okay, doesn't matter what you call it, p, q, r, s, whatever. I just randomly chose some variable. So now I want to know what angle has a sine of t. So what angle has a side length of t? That angle is negative pi over 10. Okay, let's look at the inverse tangent. Can you see that? Okay. Let's look at the inverse tangent of the tangent of negative 2 pi over 3. Okay, well, I know negative 2 pi over 3. That's negative 120 degrees. So I believe the tangent is something. Let's draw it. I don't know tangents very well off the top of my head. So this right here represents a side length. Maybe it's negative root 3 over 3. Maybe it's positive root 3. I don't know. I'm going to draw it. The actual answer doesn't really matter, though. So negative 2 pi over 3 is in the third quadrant. And this already is going to cause problems. Talking about tangent, third quadrant. So I'm about to do the inverse tangent, third quadrant, that does not fall within my range. So this is going to be problematic. These are great multiple choice questions, by the way. Is the answer going to be pi over 3, negative 5 pi over 3, etc.? So these are great multiple choice questions. So the tangent, let's see here. So this is 60 degrees. So this is negative root 3 over 2, negative 1/2. The actual value of the tangent doesn't matter, okay? I'm finding it out, but in the big picture, we don't need to know it. The value of the tangent of negative 2 pi over 3 is root 3. Okay, so now I've just evaluated that the tangent of negative 2 pi over 3 is root 3. So now I want to know the inverse tangent of root 3. Perfect. Well, who has a tangent of root 3? We just did it. We just did it. It should be negative 2 pi over 3. What's the tangent of negative 2 pi over 3? Root 3. What angle has a tangent of root 3? 2 pi over 3. Nope, nope, nope. Or negative 2 pi over 3. Nope, 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 nope. The range for the inverse tangent is negative pi over 2 to positive pi over 2. That's the range of inverse tangent right here. So my answer, negative 2 pi over 3, does not fall within that range. Okay, well, negative 2 pi over 3. So this is a positive tangent. Where else is the tangent positive? The tangent is also positive in quadrant 1. So quadrant 1, positive root 3 over 2, positive 1/2. The reference angle is still 60 degrees. So the answer to this is positive pi over 3. Well, what if I went if I went counterclockwise and I said, okay, but if I get to the third quadrant going, through the first quadrant, through the second quadrant to the third quadrant, it still falls outside of the range. Pi over 3 does, however, fall between negative pi over 2 and pi over 2. Okay, let's do another one that kind of looks like that. Let's look at the inverse sine of the sine of negative 3 pi over 4. This right here is a side length. It's root 2 over 2. It is 0.79, whatever. This represents a side length, and then I want to know what angle has that side length. Okay, so the sine of negative 3 pi over 4. So here's the issue. The range of the inverse sine curve is negative pi over 2 to positive pi over 2. Negative 3 pi over 4 does not fall in this range. So negative 3 pi over 4 is in the third quadrant. So I have some angle in the third quadrant. That's where negative 3 pi over 4 is. And I want to know an angle within the range of negative pi over 2 to positive pi over 2 that has that same value. Okay, so the sine is negative. The sine is negative in quadrant 3. Agreed? Good. The sine is also negative in quadrant 4. So whatever reference angle I get in quadrant 3, I need the same reference angle in quadrant 4. Okay, so the reference angle for negative 3 pi over 4 is 1 pi over 4. The reference angle is pi over 4. The reference angle in quadrant 4 is also going to be pi over 4, but I need to be in the fourth quadrant. So if I want negative, start at 0, negative direction, I'm going to get negative pi over 4. Okay, let me draw that for you, actually using the value. So it's a 45 degree, and I know the sine is root 2 over 2. Oh, in this case, negative root 2 over 2. This is negative 3 pi over 4. So the answer to the sine of negative 3 pi over 4, the answer to that portion of things is negative root 2. So now I'm asking you the inverse sine of negative root 2 over 2. The answer to this initial part, the initial composite, is negative root 2 over 2. And now I want to know an angle that has that same sign. Well, Miss Babiak, it's right here. Shouldn't it just be negative 3 pi over 4? Well, it's true. It is true that the sign of negative 3 pi over 4 is negative root 2 over 2, but that's not going to help me because it lies outside of the range. So what other angle has a sign of negative root 2 over 2? Quadrant 4. Quadrant 4. Negative pi over 4. Let's do some solving. All right, let's say that we have 2 inverse cosine of x is equal to pi. Let's write over this. Much better. Okay. So this means that the inverse cosine of x is pi over 2. This is the same thing as the cosine of pi over 2 equals x. The sine of some angle is pi over 2. So inverse, switch x and y. So the cosine of pi over 2 is going to be, I think that is 0. That's the key thing here, switching forms. Remember I talked about exponential form and log form? Same deal. How about -4? Inverse tangent of x is equal to pi. So the inverse tangent of x is -pi over 4. Let's change forms. So this becomes the tangent of -pi over 4 equals x. Tangent of -pi over 4. So that is the tangent of -45 degrees, which I believe is -1. Let's take a look at the inverse reciprocal functions. The inverse reciprocal functions. Okay, so now you got all those cosecants and cotangents, et cetera, et cetera, et cetera. So it's going to get pretty intense. This is a lot of evaluating. That's all it is evaluating on the unit circle. Okay, let's look at the inverse tangent. The inverse tangent of the cotangent of 2 pi over 3. Okay, so when you're finding the cotangent of the angle, great. We don't have to worry about problems with ranges and domains, et cetera, et cetera. We're just evaluating the cotangent of the angle. You can plug it straight into your calculator. So I'm still not very good at tangents and cotangents. 2 pi over 3, that's 60 degrees. Like quadrant 2, fine. Quadrant 3, quadrant 4, no problem, because I'm not talking about an inverse. So 60 degrees, this is going to be root 3 over 2, -1/2. So this is going to be the inverse tangent of -√3. Now I have to worry about my domain and range. Now I need to worry about the range in particular. So the range of inverse tangent is from -pi over 2 to +pi over 2. Write it down for yourself. The more you write it down, the more it's going to be ingrained. You're not going to have to memorize. So this is going to be, tangent is negative in quadrants 2 and 4. Tangent is negative in quadrant 2 and 4. And so we would just say, oh, it's right here. It's 2 pi over 3, but it can't be 2 pi over 3 because 2 pi over 3 does not fall into this range. So I need the equivalent of a 60-degree angle in quadrant 4. Tangent negative in 2, tangent is negative in 4. So this would be -60 degrees or -pi over 3. We are going to stick to radians. We are going to stick to radians. And I messed that up. I want the tangent is to be -√3, not the cotangent. So this should be a 30-degree. I made a mistake. This says tangent. So who has a tangent of -√3? So I'm correct and that it's in quadrant 4, but instead of being 60 degrees, it should be 30 degrees. Cotangent of 60, tangent is 30. So this should say negative pi over 6. I said, oh, cotangent negative root 3, and that's why I said 60 degrees. But because it's tangent, it should be a 30-degree reference. Sorry about that. Okay, how about things that don't lie on the unit circle? How about, well, they lie on the unit circle, but they're not ones that we know off the top of our head. So how about something like the cosine of the inverse sine of root 2 over 3? I don't know this on the unit circle, but this is some angle. This represents some angle whose sine is positive root 2 over 3. Now it's positive, it has to be in quadrant 1. It's positive, it has to be in quadrant 1. So here's my theta, here's my root 2, here's my 3. Now I want to know the cosine of that angle. So to find the cosine of that angle, I need to know my adjacent side. So x squared plus 2 equals 9. X equals root 7. So the cosine of the evaluation of this entire problem, the cosine of the inverse sine of root 2 over 3 is going to be root 7 over 3. Okay, I'm going to do one more and then we're going to get into some pure variable solving. Let's do one more. Let's do the inverse cosecant of negative 2 root 3 over 3. Cosecant, reciprocal of the sine. The range, so my answer, the domain I'm given is negative 2 root 3 over 3. The range, my answer, must be between negative pi over 2 and positive pi over 2. Okay. Cosecant, reciprocal of the sine, sine, negative, 4th quadrant. So what I need to do is find that reference angle. Find the reference angle, make it negative, we're good to go. So knowing my unit circle, I know that this has a sine of negative root 3 over 2. Reciprocal, do your unit circle, you'll get negative root 3 over 2. And that is a 60-degree reference. So I can't go all the way around. Oh, 4th quadrant. So that would be, all the way around, and that would be 300 degrees, 5 pi over 3. No, 5 pi over 3 does not fall between negative pi over 2 and positive pi over 2. So the answer to this is negative 60, which is negative pi over 3. I knew it was 60 because I took the reciprocal, which ends up being negative root 3 over 2. All right, let's do one that has a bunch of variables. And so these are the type of questions that I can very easily ask you, multiple choice, whatever, because your calculator is not going to help you. All right, let's evaluate the tangent of the inverse cosine of u. What? So we want to evaluate. I love these types of questions. This is some angle whose cosine is u. Now find the tangent of that angle. Find the tangent of the angle who has a cosine of u. Okie dokie. First quadrant, it's positive. All things positive. Cosine, adjacent over hypotenuse. I want to find the tangent. I need to know opposite over adjacent. So I need to use the Pythagorean theorem to find my missing side. U squared plus y squared equals 1. Y squared is 1 minus u squared. Y, no plus or minus. We're talking about the side length is positive in quadrant 1. So if I were in quadrant 3 or 4, I would say the negative root 1 minus u squared. But I'm in quadrant 1. So that's my y. So the tangent of the angle whose cosine is u is opposite, which is root 1 minus u squared over adjacent. Okay. I want to do one that's a little bit more intense. Like, I know this is intense, but let's do one more. I'm going to make it up. Let's hope it works. Last one. Let's do how about the secant of the inverse sine of negative u. Okay, so the sine is negative. Let's go back. So this is some angle whose sine is negative u. This is some angle, and then I want to find the secant of that angle. Okay, well, sine is negative in quadrants 3 and quadrants 4. But it has to be quadrant 4 because the range of the inverse sine function is from negative pi over 2 to positive pi over 2. So our angle is going to lie in quadrant 4. Okay, sine, opposite over hypotenuse. Okay, secant requires that I know the adjacent side. Okay, so the adjacent side squared plus negative u squared equals 1. So we have x squared equals 1 minus u squared. This is positive u squared, subtract. So x is the square root of 1 minus u squared. Okay, so this is the angle whose sine is negative u. Now I know all three side lengths. I can find the secant. Well, the secant is the reciprocal of the cosine. So the secant of this angle is going to be 1 over root 1 minus u squared. Rationalize. So my final answer is square root of 1 minus u squared all over 1 minus u squared. Make sure you know your domains and your ranges. So I would recommend, oh, lots of notes. There you go. I highly recommend knowing the domains and ranges of all of your inverse trig functions.